Welcome to Team Tarzan's demo for Hackathon 2017. Our project is called TAR, TAAR. It stands for Transport Assistance Augmented Reality. What we aimed to do was to bring augmented reality to our transport assistance database. So all transport data, regulatory data, we want to add augmented reality to be able to capture from our labels produced by Sphera software and automatically recognize them and link them to our data. Now, as you can see, this is a view from my webcam. You can see my hand, so there we go. Now, let's reach out and get a substance. In this case, fluorobenzene. You can see it's immediately acquired. The software immediately identifies it from the label. You can move it back in 3D space. It's tracking it. It knows where it is. It knows what it is. The label acquisition is also very fast. It's done every frame of the video, and we can find the labels very, very quickly this way. This works by reading the 2D barcodes that we've added to the labels. These barcodes have IDs that link back to our database, and then from the Transport Assistance database, we get all our data. Now, if you click on one, you get a detailed panel that shows you the UN number, label, packing group, and all that extra information. Now, because we have all this positional information too, we know where the box is in space, and we know where it is, we know what product it is. Well, we can also bring something else in, and then from here we can identify potential hazard problems, like essentially putting a flammable substance next to an oxidizer. It then warns you of the hazard. If we move them apart just far enough, the warning will go away. There we go. Warning goes away. So from here, we can move it all the way back, take the other product, the hydrogen peroxide, the oxidizer, move it back next to the flammable product, and again, goes red, starts warning that they shouldn't be next to each other. Now, this also works for tons of other products. We can just keep bringing boxes, and they'll all test themselves relative to each other, bring up the necessary warnings. Another hazardous condition we can identify is, what if a product falls over? What if a box fell over? Now it says container not upright. So we can even detect orientation of a box and a product and see where the container, how it's located. Upside down, they're both complaining that they're not upright. Turn it back again, the warnings go away. Now it's warning again that ammonium nitrate should not be close to an oxidizer. That's not a good idea. Now, with these capabilities, you can imagine wiring up a warehouse with a series of webcams and automatically capturing all your inventory around in real time. If a box is moved or anything is misplaced, you already know where it is. You could have that all mapped out. And also you could identify possible hazardous situations and immediately send off email to a supervisor so it could be remedied immediately. Now, what if you needed this for an inspector or first responders in the field that need to identify what products were spilled or something like that? For those scenarios, you need the software running on a phone. So in this case, what we see on the webcam also works on a mobile platform. So I'm going to bring in a phone, which doesn't work really well with my hand. So okay. Now you can see the phone is acquiring these products. It's already finding them. It's competing with the webcam right now because they're on the same feed. But the phone is tracking all of our chemical products. So I'm going to pass the phone to my colleague Phil here, and he's going to continue the rest of the demo. Now let's switch also to a view of the phone. Now we can see what's happening on the phone. Let's maximize this. Okay, so Phil is walking towards a wall covered in labels. This is like a wall in a warehouse. Immediately the phone acquires everything. It's a little choppy because we're feeding the phone screen to the computer and then recording, so there's a bit of smoothness loss, but it's very smooth on the phone. So here we can acquire, like this was 9 products all at once. Well, we were only seeing 8, there's one that's off frame, but all at once very quickly, and we're all tracking them, discovering the warnings. This software works on a lot of targets, very quickly identify all our labels so you could capture everything at once, allowing an inspector to go through your warehouse and capture everything quickly, do his job, get the reports, immediately track any situations that are bad. The other thing you can do is if you tap one of these, you get the same detail panel as before, but now you can go and click View Detail and launch our mobile app for transport assistance. And from here, you can go and pull the data that's in Transport Assistant, get all the richness of the information, the packing code again, and drill down further and get really all that information. And this is connecting back to our database, back to all this information, like from the UN code, what can you do, how can you package this, all of that. You could also, like the situation of a truck spill, well, the driver could file a first report, an incident report from his phone and go scan which products were involved in the incident and what he was carrying. Also from here, you could connect to any other Sphera product throughout our entire system and do any required actions you need at the time. So let's go back to our slides now. So what we built is essentially a system that allows you to rapidly scan your inventory, detect hazardous items and hazardous situations, provide transporter information using augmented reality and connecting to our data link and our data, and also auto-detect the Sphera labels. We can just read the labels based on the barcodes. From here, we can also acquire a lot of labels simultaneously and quickly, like you saw with the phone demo when Phil was coming to the wall, and detect hazardous situations based on their spatial positionings. So you could even like have a drone flying through the warehouse, scanning everything, looking for any bad conditions, or monitor a truck being loaded, keep track of what goes in the truck, compare it to the manifest, and see if there's a match. Other things the software can look for is, did you stack too many packages on top of each other? Some things are not allowed to be stacked higher than 3, for example. And just by knowing the position of everything, we can know if it's stacked too high. We could also look for cases where a corrosive product was stacked on top of a product reactive with oxygen. And you wouldn't want that because if the corrosive product leaks, it could damage the container of the other product, causing a bad reaction. The mobile version of Transport Assistant opens up the richness of the data of the transport data that we have in our data link and in Transport Assistant itself. And from there, you can drill down into all the information about like the packing group, the information how things need to be shipped, opening the door through the web to all our data, all our stored information in our data link. So our whole process is pretty simple. We go from identifying a label, tracking it in space, and letting the user interact with the label on the phone, and then connect to our transport data through a REST service with all of our database. And that is it for Transport Assistant Augmented Reality. Thank you very much.